In this topic, we will be looking at tangents, specifically straight lines tangential to curves. So tangents are used when designing to get a smooth transition between lines and curves. So if we have a straight line here and we have a curve, there must be a smooth transition. The point of tangency. So if you have a point and a circle, and you were to draw a line, a straight line from that point to a circle that touches the circumference of the circle, the point where the line touches the circle is called the point of tangency. Now, if you draw a line from the point of tangency to the center of the circle, that line is called a normal. It's important to note that the angle between the tangent and the normal is always 90 degrees. Now, to define tangents, a line, curve, or surface touching but not intersecting another. A straight line touching the circumference of a circle at one point and perpendicular to the normal. A normal is a straight line drawn from the center of the circle extending beyond the circumference. The tangent and the normal meet at an angle of 90 degrees. Another important fact, any triangle within a semicircle with one side on its diameter will be a right angle triangle. If you have a semicircle and a triangle with one side on the diameter, the angle on the circumference will be 90 degrees. And this happens for any triangle within that semicircle. The next construction we're going to be doing to draw a tangent to a circle from a point outside the circle. So we have our point P there, and we have our circle. Now the first thing that we would do, we're going to use that principle of the semicircle. So we're going to connect the centers, P to the center of the circle, and draw a semicircle. Now that point where the semicircle cuts the circumference of the circle, we draw a line to the center of the circle. That line would be a normal. Next, we draw a line from point P to the normal where is cut by the semicircle, forming the triangle. So we know that triangle is going to be 90 degrees, and that point where the tangent meets the normal will give you your point of tangency. Next, we're going to look at to draw the common internal tangent to two equal circles. And the common internal tangent is where we have a line that's passing in between two circles. Now, if this is from a point to one circle, if we put the point in between the two circles or midway between the two circles and repeat the construction, then we will get the tangent passing in between two circles. Next construction, to draw the common external tangents to two unequal circles. So we're working with this scenario here. External tangent is passing on the outside of two unequal circles. So we have one circle, radius r, and we have another circle of radius small r. Now from the center of the small circle to the center of the bigger circle, we're going to draw our semicircle. Now, let's look at the tangent. The tangent is passing on the outside. But let's say we wanted to get a tangent to point 0 as the starting. So a tangent from point 0 to a circle. I will need a construction circle. Now what is happening here? We took the small circle, radius of the small circle, from the radius of the big circle. What that does is that it gives us a normal, which will give us a tangent from the center of the small circle to that circle, construction circle. Now, this is similar to the tangents that we know how to construct from a point to a circle. Now, how does this relate to getting the tangent to the two unequal circles? Well, the tangent will be actually on the outer circle, so we could just translate that point from our inner construction circle to the outer circle and do the same thing to our small circle. And so we have transferred the tangent from a point to a circle to the two unequal circles. So that gives us our tangent and our point of tangency. Next, we're going to look at to draw a common internal tangent to two unequal circles. So the common internal tangents look like this. We have our circles of radius big R and small r. And to begin with, we draw that semicircle. We always start with drawing the semicircle from both centers. This time we're going to be using a construction line that's going to be equal to R plus R. What that does is that it gives us a normal that will give us a tangent to the center of the small circle. And with that now, we take the distance from the construction circle to the required circle R and transfer it onto the smaller circle. And that gives us the points where to draw our tangent, which will be the common internal tangent to the two unequal circles. And those points there will give us the points of tangency. Now let's apply these principles to the figure shown there. Alright, the figure shows the outline of a template, and we want to draw this template given these dimensions. Now the final drawing looks something like this here, where you have the tangents to show how we get between the smooth transition from the lines to the curve will look like this. Now the drawing looks confusing. So how we would approach a question like this, we would first draw the given circles. We will work on one tangent at a time. So for instance, we will look at the tangent between the two larger circles, they are unequal, and the tangent is on the outside. So it's a common external tangent to two unequal circles, and we apply that construction. When we have finished applying that construction to those two circles, we look at the other two circles. In this case, we look at this situation here, where you have a common internal tangent to these two circles. We do the third one, which is a common external tangent to two unequal circles. So just to recap, they do each tangent separate to make up the drawing.